a body of mass m is taken from the Earth's surface to the height equal to twice the radius of the Earth, what will be the change in potential energy of the body? In order to calculate the change in potential energy of a body, which is taken from the Earth's surface to a height equal to twice the Earth's radius, which means h is equal to 2r, we use the formula for gravitational potential energy, which is nothing but U is equal to minus gmm by r, where g is the gravitational constant, capital M is the mass of the Earth, small m is mass of the body, and r is the distance of the body from the Earth's center. At the Earth's surface, the distance of the body from the Earth's center is equal to radius of the Earth. Therefore, we get initial potential energy given by U initial is equal to minus gmm by r. At height h is equal to 2r, the distance from the Earth's center is r is equal to r plus h, and h is equal to 2r. Therefore, we get r is equal to r plus 2r, which is nothing but 3r. The potential energy at this point is U final is equal to minus gmm by 3r. The change in potential energy is given by delta U is equal to final potential energy minus initial potential energy. Now substituting U final and U initial in this formula, we get delta U is equal to minus gmm by 3r minus of minus gmm by r. On simplifying and taking common denominator, we get delta U is equal to gmm by r into 2 by 3. Now substituting the value of gm as gr square, we get delta U is equal to gr square m by r into 2 by 3. R square by r cancels out and r remains. Therefore, the final answer is delta U is equal to 2 by 3 mgr. And the correct answer is option A, 2 by 3 mgr.